Okay, this evening we're going to deal with concepts above concepts. So we're going to be dealing with metaphysics, which is the meta is above physics. And this leads us into metamathematics, which we're going to argue is more fundamental than metaphysics, and the Ruliad, which is an algorithmic representation of all of this. So let's get going here. Hold on a second while I get this thing cranked up. Here we go. Okay. So here you see it. Metamathematics, metaphysics, and the Ruliad. And we're going to be dealing with the concepts of epistemology, metaphysics, and they have an overlap here. And then ontology, which is completely contained within metaphysics. The Ruliad is represented by this graphic here that may or may not mean anything to you, but it's a graph, and so it has nodes and it has edges to it, but it's incredibly complicated. And here we see the chakras, and what goes with that is the aura that comes out of the chakras that we deal with. All of this would be viewed as metaphysical, but I'm going to argue it's going to be metamathematical. So here we go. We're just going to deal with a lot of basic concepts here to try and set terms, because a lot of this isn't something that you can really dig into, but it'll give you a framework for thinking about all of this. And so that's the goal for tonight. The definition of victory is to come away with the framework of what is above what you think is reality. So here we have metaphysics is the branch of philosophy that examines the basic structure of reality. Couldn't get more basic than that. It's traditionally seen as the study of mind-independent features of the world. In other words, the observer doesn't impact anything, but some theorists view this as an inquiry into the conceptual framework of human understanding. So here we could argue that the observer is in fact influencing the features of the world. Some philosophers, including Aristotle, designate metaphysics as the first philosophy to suggest that it's more fundamental than other forms of philosophical inquiry. And again, we'll argue that metamathematics is more fundamental than metaphysics. So metaphysics encompasses a wide range of general and abstract topics. It investigates the nature of existence, the features all entities have in common, their division into categories of being, and there's an influential division between particulars and universals. Some things are very narrow, the particulars and universals encompass everything. Particulars are individual unique entities, like a specific apple. Universals are general features that different particulars have in common, like the color red. And modal metaphysics examines what it means for something to be possible or necessary. So metaphysicians explore the concept of space, time, and change and their connection to causality and the laws of nature. Other topics include how the mind and matter are related, whether everything in the world is predetermined, and whether there is free will. So you can see this is really basic. Metaphysicians traditionally rely on rational intuition and abstract reasoning, but recently have included empirical approaches that are associated with scientific theories. Now, due to the abstract nature of its topic, metaphysics has received criticisms questioning the reliability of its methods, the meaningfulness of its theories. What can I do now that I couldn't do before? Metaphysics is relevant to many fields of inquiry that often implicitly rely on metaphysical concepts and assumptions. So the roots of metaphysics lie in antiquity, with speculations about the nature and origin of the universe, like those found in the Upanishads in ancient India, Taoism in ancient China, and pre-Socratic philosophy in ancient Greece. During the subsequent medieval period in the West, discussions about the nature of universals were influenced by the philosophies of Plato and Aristotle. And the modern era saw the emergence of various comprehensive systems of metaphysics, many of which embraced idealism. In the 20th century, traditional metaphysics in general, and idealism in particular, faced various criticisms, which prompted new approaches to the metaphysical inquiry. Metaphysics is the study of the most general features of reality, including existence, objects and their properties, possibility and necessity, space and time, change, causation, and the relation between matter and mind. It's one of the oldest branches of philosophy. The precise nature of metaphysics is disputed. Its characterizations have changed in the course of history, and some approaches see metaphysics as a unified field with wide sweeping definition by understanding it as the study of fundamental questions about the nature of reality, or as an inquiry into the essence of things. Another approach doubts that the different areas of metaphysics share a set of fundamental underlying features and provide instead a finer-grained characterization by listing all the many topics investigated by metaphysics. And some of these definitions are descriptive by providing an account of what metaphysics does, while others are normative and prescribe what metaphysics ought to do. The two historically influential definitions in ancient and medieval philosophy understand metaphysics as the science of the first causes and as the study of being qua being, that is, the topic of what all beings have in common and to what fundamental categories they belong. In the modern period, the scope of metaphysics expanded to include such topics as the distinction between mind, body, and free will. Some philosophers follow Aristotle in describing metaphysics as first philosophy, suggesting it's the most basic inquiry upon which all the other branches of philosophy depend. So metaphysics is traditionally understood as a study of mind-independent features of reality, starting with Kant's critical philosophy. An alternative conception gained prominence that focused on conceptual schemes rather than external reality. Kant distinguished transcendent metaphysics, which aims to describe the objective features of reality beyond the sense experience, from the critical perspective on metaphysics, which outlines the aspects and principles underlying all human thought and experience. Strawson further explored the role of conceptual schemes, contrasting descriptive metaphysics, which articulates conceptual schemes commonly used to understand the world, with revisionary metaphysics, which aims to produce better conceptual schemes. So metaphysics differs from the individual sciences by studying the most general and abstract aspects of reality. The individual sciences, by contrast, examine more specific and concrete features and restrict themselves to certain classes of entities, such as the focus on physical things in physics, living entities in biology, and cultures in anthropology. So it's disputed to what extent this contrast is a strict dichotomy rather than a gradual continuum. The word metaphysics had its origin in the ancient Greek words meta meaning after or above and beyond, and physica, short term of ta meta or ta physica, meaning what comes after the physics. So it's above or beyond the physics. This is often interpreted to mean that metaphysics discusses topics due to their generality and comprehensiveness lie beyond the realm of physics and its focus on empirical observation. Metaphysics may have received its name by a historical accident when Aristotle's book on the subject was published. Aristotle did not use the term metaphysics, but his editor may have coined it for its title to indicate that this book should be studied after Aristotle's book published on physics, literally after physics. The term entered the English language through the Latin word metaphysica. The nature of metaphysics can also be characterized in relation to its main branches. An influential division from early modern philosophy distinguishes between general and special or specific metaphysics. General metaphysics, which is also called ontology, takes the widest perspective, studies the most fundamental aspects of being, investigates the features that all entities share, how the entities can be divided into different categories. Categories are the most general kind, such as substance, property, relation, and fact. Ontologists research which categories there are, how they depend on one another, and how they form a system of categories that provides a comprehensive classification of all entities. Special metaphysics considers being from more narrow perspectives and is divided into subdisciplines based on the perspective they take. Metaphysical cosmology examines changeable things and investigates how they're connected to form a world as a totality extending through space and time. Rational psychology focuses on metaphysical foundations and problems concerning the mind, such as its relation to matter and the freedom of the will. Natural theology studies the divine and its role as the first cause. The scope of special metaphysics overlaps with other philosophical disciplines, making it unclear whether a topic belongs to it or to areas like philosophy of the mind and theology. So starting in the second half of the 20th century, applied metaphysics was conceived as the area of applied philosophy examining the implications and use of metaphysics, both within philosophy and other fields of inquiry. In areas like ethics and philosophy of religion, it addresses topics like the ontological foundations of moral claims and religious doctrines. But beyond philosophy, its applications include the use of ontologies in artificial intelligence, economics, and sociology to classify entities in psychiatry and medicine, and then examines the metaphysical status of diseases. Metaphysics is the meta-theory of metaphysics and investigates the nature and methods of metaphysics. It examines how metaphysics differs from other philosophical and scientific disciplines and assesses its relevance to them, even though discussions of these topics have a long history in metaphysics. Metaphysics has only recently developed into a systematic field of inquiry. So metaphysicians often regard existence or being as one of the most basic and general concepts. To exist means to be part of reality, distinguishing real entities from imaginary ones. According to a traditionally influential view, existence is a property of properties. If an entity exists, then its properties are instantiated. A different position states the existence is a property of individuals, meaning that it is similar to other properties such as shape or size. But it's controversial whether all entities have this property. According to philosopher Meinong, there are non-existent objects, including merely possible objects like Santa Claus and Pegasus. A related question is whether existence is the same for all entities, whether there are different modes or degrees of existence. For instance, Plato held that Platonic forms, which are perfect and immutable ideas, have a higher degree of existence than matter, which can only imperfectly reflect Platonic forms. Another key concept in metaphysics is the division of entities into distinct groups based on the underlying features they share. These theories of categories provide a system, the most fundamental kind, or the highest genera of being by establishing a comprehensive inventory of everything. One of the earliest theories of categories was proposed by Aristotle, who outlined a system of 10 categories. He argued that substances, for example, man and horse, are the most important category, since all other categories like quantity, for example, 4, or quality, for example, white, and place, for example, in Athens, are said of substances and depend on them. So Kant understood categories as the fundamental principles underlying human understanding and developed a system of 12 categories divided into 4 classes: quantity, quality, relation, and modality. More recent categories were proposed by Peirce, Husserl, Samuel Alexander, and on and on. Many philosophers rely on the contrast between concrete and abstract objects. According to a common view, concrete objects like rocks, trees, and human beings exist in space and time, undergo changes, and impact each other as cause and effect. But they contrast with abstract objects like numbers and sets, which do not exist in space and time, are immutable, and do not engage in causal relations. Particulars are individual entities and include both concrete objects like Aristotle or the Eiffel Tower or a specific apple, and abstract objects like the number 2 or a specific set in mathematics. They are unique, non-repeatable entities in contrast with universals like the color red, which can at the same time exist in several places and characterize several particulars. A widely held view is that particulars instantiate universals, but are not themselves instantiated by something else, meaning they exist in themselves while universals exist in something else. Substratum theory, associated with John Locke's philosophy, analyzes each particular as a substratum, also called a bare particular, together with various properties. So the substratum confers individuality to the particular, while the properties express its qualitative features or what it is like. This approach is rejected by bundle theorists, inspired by David Hume's philosophy. They state that particulars are only bundles of properties that are an underlying substratum. Some bundle theorists include in the bundle an individual essence called aestheticity, following scholastic terminology, to ensure that each bundle is unique. Another proposal for concrete particulars is they're individuated by space-time location. Concrete particulars encountered in everyday life, like rocks, tables, and organisms, are complex entities composed of various parts. For example, a table consists of a tabletop and legs, each of which is itself made up of countless particles. The relation between parts and whole is a study of mereology. The problem of the many is a philosophical question about the conditions under which several individual things compose a larger whole. For example, a cloud comprises many droplets without a clear boundary, raising the question of which droplets form part of the cloud. According to mereological universalists, every collection of entities form a whole. This means that what seems to be a single cloud is an overlay of countless clouds, one for each cloud-like collection of water droplets. Mereological moderists hold that certain conditions must be met for a group of entities to compose a whole. For example, the entities have to touch one another. Mereological nihilists reject the idea of wholes together, claiming there are no clouds or tables, but only particles that are arranged cloud-wise or table-wise. A related mereological problem is whether there are simple entities that have no parts, as atomic theorists claim, or whether everything can be endlessly subdivided into smaller parts, as continuum theorists contend. Universals are general entities encompassing both properties and relations that express what particulars are like and how they resemble one another. They're repeatable, meaning they're not limited to a unique existent, but can be instantiated by different particulars at the same time. For example, the particulars Nelson Mandela and Mahatma Gandhi instantiate the universal humanity, similar to how a strawberry and a ruby instantiate the universal red. A topic discussed since ancient philosophy, the problem of universals consists in the challenge characterizing the ontological status of the universals. Realists argue that the universals are real, mind-independent entities that exist in addition to particulars. According to Platonic realists, universals exist independently of particulars, which implies that the universal red would continue to exist even if there were no red things. A more moderate form of realism inspired by Aristotle states that universals depend on particulars, meaning that they are only real if they are instantiated. Nominalists reject the idea that universals exist in either form. For them, the world is composed exclusively of particulars. Conceptualists offer an intermediate position, stating that universals exist, but only as a concept in the mind used to order experience by classifying entities. Natural and social kinds are often understood as special types of universals. Entities belonging to the same natural kind share certain fundamental features characteristic of the structure of the natural world. So in this regard, natural kinds are not an artificially constructed classification, but are discovered usually by the natural sciences, and include things like electrons, H2O, and tigers. Scientific realists and anti-realists disagree about whether natural kinds exist. Social kinds, like money or baseball, are studied by social metaphysics and characterized as useful social constructions that, while not purely fictional, do not reflect the fundamental nature of mind-independent reality. The concepts of possibility and necessity convey what can or must be the case expressed in modal statements, like it's possible to find a cure for cancer, and it is necessary that 2 + 2 = 4. Modal metaphysics studies metaphysical properties surrounding possibility and necessity, for instance, why some modal statements are true while others are false. Some metaphysicians hold that modality is a fundamental aspect of reality, meaning that besides facts about which it is the case, there are additional facts about what could or must be the case. A different view argues that modal truths are not about an independent aspect of reality, but can be reduced to non-modal characteristics. For example, the facts about what properties or linguistic descriptions are compatible with each other, or to fictional statements. Borrowing a term from German philosophy, Leibniz theodicy, many metaphysicians use the concept possible worlds to analyze the meaning and ontological ramifications of modal statements. A possible world is a complete and consistent way the totality of things could have been. For example, the dinosaurs are wiped out in the actual world, but there are possible worlds in which they're still alive. According to possible world semantics, a statement is possibly true if it is true in at least one possible world, whereas it is necessarily true if it is true in all possible worlds. Modal realists argue that possible worlds exist as concrete entities in the same sense as the actual world, with the main difference being that the actual world is the world we live in, while the other possible worlds are inhabited by counterparts. This view is controversial and various alternatives have been suggested. For example, that possible worlds only exist as abstract objects or are similar to stories told in the works of fiction. Space and time are dimensions that entities occupy. Space-time realists state that space and time are fundamental aspects of reality and exist independently of the human mind. Space-time realists, by contrast, hold space and time are constructs of the human mind created to organize and make sense of reality. Space-time absolutism, or substantialism understands space-time as a distinct object, some metaphysical conceptualizing it as a container that holds all other entities within it. Space-time relationship sees space-time not as an object, but as a network of relations between objects, such as the spatial relation of being next to and the temporal relation of coming before. In the metaphysics of time, an important contrast between the A series and the B series. According to the A series theory, flow of time is real, meaning the events are categorized into the past, present, and future, while the present continually moves forward in time, and events that are in the present now will eventually change that status and lie in the past. From the perspective of the B series theory, time is static. Events are ordered by the temporal relation earlier than and later than, without any essential differences between past, present, and future. Eternalism holds that past, present, and future are equally real, whereas presentism asserts that the only entities in the present exist. Material objects persist through time and change in the process, like a tree that grows or loses leaves. The main ways of conceptualizing persistence through time are endurantism and perentism. According to endurantism, material objects are three-dimensional entities that are wholly present at each moment. As they change, they gain or lose properties, but otherwise they remain the same. Perentis see the material objects as four-dimensional entities that extend through time and are made up of different temporal parts. At each moment, only part of the object is present, not the object as a whole. So change means that an earlier part is qualitatively different from a later part. For example, when a banana ripens, there's an unripe part followed by a ripe part. Causality is the relation between cause and effect, whereby one entity produces or alters another entity. For instance, if a person bumps a glass, spills its content, then the bump is the cause, and the spill is the effect. Beside the single case causation between particulars in this example, there's also general case causation expressed in statements such as smoking causes cancer. The term agent causation is used when people and their actions cause something. Causation is usually interpreted deterministically, meaning that a cause always brings about its effect. However, some philosophers have provided counterexamples to this idea, and such counterexamples have inspired the development of probabilistic theories, which claim that the cause merely increases the probability that the effect occurs. This view can explain that smoking causes cancer, even though this does not happen in every single case. The irregular theory of causation, inspired by David Hume's philosophy, states that causation is nothing but a constant conjunction in which the mind apprehends that one phenomenon, like putting one's hand in a fire, and is always followed by another phenomenon, like a feeling of pain. According to gnomic regularity theories, regularities manifest as laws of nature studied by science. Counterfactual theories focus not on regularities, but on how effects depend on their causes. They state that effects owe their existence to the cause and would not have occurred without them. According to primitivism, causation is a basic concept that cannot be analyzed in terms of non-causal concepts, such as regularities or dependence relations. One form of primitivism identifies as causal powers inherent in entities as the underlying mechanism, but eliminatalists reject the above theories by holding that there is no causation. Mind encompasses phenomena like thinking, perceiving, feeling, desiring, as well as the underlying faculties responsible for these phenomena. The mind-body problem is the challenge of clarifying the relation between physical and mental phenomena. According to Cartesian dualism, René Descartes, minds and bodies are distinct substances. They causally interact with each other in various ways, but can at least in principle exist on their own. This view is rejected by monists, who argue that reality is made up of only one kind. According to metaphysical idealism, everything is mental or dependent on the mind, including physical objects, which may be understood as ideas or perceptions of conscious minds. Materialists, by contrast, state that all reality is at its core material. So some deny that mind exists, but the more common approach is to explain mind in terms of certain aspects of matter, such as brain states, behavioral dispositions, or functional roles. Neutral monists argue that reality is fundamentally neither material nor mental and suggest that matter and mind are both derivative phenomena. A key aspect of the mind-body problem is the hard problem of consciousness, or how to explain that physical systems like brains can produce phenomenal consciousness. The status of free will is the ability of a person to choose their actions, is a central aspect of the mind-body problem. Metaphysicians are interested in the relation between free will and causal determinism, the view that everything in the universe, including human behavior, is determined by preceding events and the laws of nature. It's controversial whether causal determinism is true, and if so, whether this would imply there's no free will. According to incompatibilism, free will cannot exist in a deterministic world since there's no true choice if everything is determined. But hard determinists infer from this that there is no free will, whereas libertarians conclude that determinism must be false. Compatibilists offer a third perspective, arguing that determinism and free will do not exclude each other. For instance, because a person could still act in tune with their motivation and choices, even if they're determined by other forces. Free will plays a key role in ethics regarding the moral responsibility people have for what they do. Metaphysicians employ a variety of methods to develop a metaphysical theory and formulate arguments for and against them. Traditionally, a priori methods have been the dominant approach. They rely on rational intuition and abstract reasoning from general principles rather than sensory experience. A posteriori approaches, by contrast, ground metaphysical theories in empirical observation and scientific theories. So some metaphysicians incorporate perspectives from fields such as physics, psychology, linguistics, and history into their inquiry. The two approaches are not mutually exclusive. It's possible to combine elements from both. But the method a metaphysician chooses often depends on their understanding of the nature of metaphysics. For example, whether they see it as an inquiry into the mind-independent structure of reality, as metaphysical realists claim, or the principles underlying thought and experience, as some metaphysical anti-realists contend. Despite its status as one of the main branches of philosophy, metaphysics has received numerous criticisms concerning its legitimacy as a field of inquiry. One criticism argues that metaphysical inquiry is impossible because humans lack the cognitive capacities needed to assess the ultimate nature of reality. This line of thought leads to skepticism about the possibility of metaphysical knowledge. Empiricists often follow this idea, like Hume, who asserts there's no good source of metaphysical knowledge, since metaphysics lies outside the field of empirical knowledge and relies on dubious intuitions about the realm beyond sensory experience. Arguing that the mind actively structures experience, Kant criticizes traditional metaphysics for its attempt to gain insight into the mind-independent nature of reality. He asserts knowledge is limited to the realm of possible experience, meaning that humans are not able to decide questions like whether the world has a beginning in time or is infinite. A related argument favoring the unreliability of metaphysical theorizing points to the deep and lasting disagreements about metaphysical issues, suggesting a lack of overall progress. Another criticism holds that the problem lies not with human cognitive abilities, but with metaphysical statements themselves, which some claim are neither true nor false, but meaningless. According to logical positivists, for example, the meaning of a statement is given by the procedure used to verify it, usually through the observations that would confirm it. So based on this controversial assumption, they argue that metaphysical statements are meaningless since they make no testable predictions about experience. A slightly weaker position allows metaphysical statements to have meaning, while holding that metaphysical disagreements are merely verbal disputes about different ways to describe the world. According to this view, the disagreement in the metaphysics of composition about whether they're tables or only particles arranged table-wise is a trivial debate about linguistic preferences without any substantive consequences for the nature of reality. The position that metaphysical disputes have no meaning or no significant point is called metaphysical or ontological deflationism. This view is opposed by the so-called serious metaphysicians who contend that metaphysical disputes are about substantial features of the underlying structure of reality. A closely related debate between ontological realists and anti-realists concerns the question of whether there are any objective facts that determine which metaphysical theories are true. A different criticism formulated by pragmatists sees the fault of metaphysics not in its cognitive ambitions or the meaninglessness of its statements, but in its practical irrelevance and lack of usefulness. Martin Heidegger criticized traditional metaphysics, saying it fails to distinguish between individual entities and beings as their ontological ground. His attempt to reveal the underlying assumptions and limitations in the history of metaphysics to overcome metaphysics influenced others. Jacques Derrida employed this approach to criticize metaphysical texts for relying on opposing terms like presence and absence, which he thought were inherently unstable and contradictory. There's no consensus about the validity of these criticisms and whether they affect metaphysics as a whole or only certain issues or approaches in it. For example, it could be the case that certain metaphysical disputes are merely verbal, while others are substantive. Metaphysics originated in the ancient period from speculations about the nature and origin of the cosmos. In ancient India, starting in the 7th century BCE, the Upanishads were written as religious and philosophical texts, examining how ultimate reality constitutes the ground of all being. They further explore the nature of the self, how it can reach liberation by understanding ultimate reality. This period also saw the emergence of Buddhism in the 6th century BC, which denies the existence of an independent self and understands the world as a cyclic process. And about the same time in ancient India, the school of Taoism with Lao Tzu was formed and explored the natural order of the universe known as the Tao or the Way, and how it is characterized by the interplay of yin and yang as two correlated forces. In ancient Greece, metaphysics emerged in the 6th century BC, with the pre-Socratic philosophers gave rational explanations of the cosmos as a whole by examining first principles from which everything arises. Building on their work, Plato, from 427 BC to 347 BC, formulated his theory of forms, which states that eternal forms or ideas possess the highest kind of reality, while a material world is only an imperfect reflection of them. Aristotle, 384 BC to 322 BC, accepted Plato's ideas that there are universal forms, but held they cannot exist on their own but depend on matter. He also proposed his system, categories, and developed a comprehensive framework of the natural world through his theory of the four causes. Starting in the 4th century BC, Hellenistic philosophy explored the rational order underlying the cosmos and the laws governing it. Neoplatonism emerged toward the end of the ancient period in the 3rd century of the modern era and introduced the ideas of the One as the transcendent and ineffable source of all creation. Meanwhile, in India, Buddhism, the Madhyamaka school, developed the idea that all phenomena are inherently empty without a permanent essence. The consciousness-only doctrine of the Yogacara school states that experienced objects are mere transformations of consciousness and do not reflect external reality. The Hindu school of Samkhya philosophy introduced a metaphysical dualism with pure consciousness and matter as its fundamental categories. In China, the school of Zhuangzi explored metaphysical problems such as the contrast between being and non-being. Medieval Western philosophy was shaped by ancient Greek thought as philosophers integrated these ideas with Christian teachings. Boethius, 477 to 524 CE, the Common Era, sought to reconcile Plato and Aristotle's theories of universals, proposing that universals can exist both in matter and mind. His theory inspired the development of nominalism, conceptualism, as the thought of Peter Abelard, 1079 to 1142 CE. Thomas Aquinas understood metaphysics as the discipline investigating different meanings of being, such as the contrast between substance and accident, and principles applying to all beings, such as the principle of identity. There also is an issue here of frame of reference. I read Aquinas, and Aquinas said, is there a God? And he said, well, we have something that we call God, so therefore there is a God. Ergo, I proved what I was trying to prove. I honestly was scratching my head over how to make sense of this, but if you were Aquinas and you lived in the 1200s, it probably made sense to you. William of Ockham, 1285 to 1347, developed a methodological principle known as Occam's razor to choose between competing metaphysical theories. That which was the simplest and that explained everything was the one that more than likely was true. Arabic Persian philosophy flourished from the early 9th century to the late 12th century and integrated ancient Greek philosophies to interpret, clarify the teachings of the Quran. Avicenna, 980 to 1037, developed a comprehensive philosophical system that examined the contrast between existence and essence and distinguished between contingent and necessary existence. Medieval India saw the emergence of the monist school of Advaita Vedanta in the 8th century CE, which holds that everything is one, and the idea of many entities existing independently is an illusion. In China, Neo-Confucianism rose in the 9th century and explored the concept of Li as the rational principle that is the ground of being and reflects the order of the universe. In the early modern period, renewed interest in Platonism during the Renaissance, René Descartes, 1596 to 1650, developed a substance dualism, according to which body and mind exist as independent entities that causally interact. The idea was rejected by Spinoza, 1632 to 1677, who formulated a monist philosophy suggesting there's only one substance, both physical and mental attributes that develop side by side without interacting. Leibniz, 1646 to 1716, introduced the concept of possible worlds and articulated a metaphysical system known as monadology, which views the universe as a collection of simple substances synchronized without causal interactions. Christian Wolff, 1679 to 1754, conceptualized the scope of metaphysics by distinguishing between general and special metaphysics. George Berkeley viewed everything as mental, including material objects, which are ideas perceived by the mind. David Hume made various contributions to metaphysics, including the regularity theory of causation and the idea that there's no necessary connection between distinct entities. And inspired by this empiricism of Francis Bacon and John Locke, Hume criticized metaphysical theories that seek ultimate principles inaccessible to sensory experience. Kant embraced this critical outlook and tried to reconceptualize metaphysics as an inquiry into the basic principles and categories of thought and understanding, rather than seeing it as an attempt to comprehend mind-independent reality. Many developments in the later modern period were shaped by Kant's philosophy. German idealists adopted his idealistic outlook to their attempt to find a unifying principle as the foundation of all reality. George Hegel, idealistic contention is that reality is conceptual all the way down and that being itself is rational. He inspired Bradley the British idealist who interpreted Hegel's concept of absolute spirit as the all-inclusive totality of being. Schopenhauer was a strong critic of German idealism and articulated a different metaphysical vision, positing a blind and irrational will as the underlying principle of reality. This comes close to what Jung believed, that there's a collective unconsciousness that's the underlying principle of reality. Pragmatists such as Peirce and John Dewey conceived metaphysics as an observational science of the most general features of reality and experience. So at the turn of the 20th century in analytical philosophy, Bertrand Russell and George Moore led a revolt against idealism, arguing for the existence of a mind-independent world aligned with common sense and empirical science. Logical atomists like Russell and Wittgenstein conceived the world as a multitude of atomic facts, which later inspired metaphysics from people like Armstrong. Alfred North Whitehead developed process metaphysics as an attempt to provide a holistic description of both the objective and the subjective realms, and Rudolf Carnap and other logical positivists formulated a wide-ranging criticism of metaphysical statements, arguing that they're meaningless because there's no way to verify them. Other criticisms of traditional metaphysics identified misunderstandings of ordinary language as a source of many metaphysical problems, or challenged complex metaphysical deductions by appealing to common sense. So the decline of logical positivism led to a revival of metaphysical theorizing. Quine tried to naturalize metaphysics by connecting to the empirical sciences, and his student David Lewis employed the concept of possible worlds to formulate his modal realism. Saul Kripke helped revise discussions of identity and essentialism, distinguishing necessity as a metaphysical notion from the epistemic notion of a priori. In continental philosophy, Husserl engaged ontology through a phenomenological description of experience, while his student Martin Heidegger developed fundamental ontology to clarify the meaning of being. And Heidegger's philosophy inspired Jacques Derrida criticism of metaphysics. Gilles Deleuze approach to metaphysics challenged traditionally influential concepts like a substance, essence, and identity by reconceptualizing the field through alternative notions such as multiplicity, event, and difference. And that takes us up to the present, and we're taking a different turn here. We're going to deal with metamathematics. And one of the things that many people have observed over a period of time is that mathematics appears to be unnaturally well suited to describing the world around us. And in fact, what this individual, Stephen Wolfram, would say is that the world around us is in fact described by a set of rules, which would be called metamathematics, because they're above mathematics. They're algorithms, but they run on many, many, many parallel processors. He calls this the Ruliad, the rule of rules. And his physics project goes into this foundational area here of metamathematics and Ruliad. I believe that this approach will be the most fruitful approach for the next period of time in dealing with metaphysics. Underneath everything we physically experience, there's a single very general abstract structure, which is called the Ruliad. All physical laws arise in an inexorable way from the particular samples we take of the structure. So it's an entangled limit of all possible combinations, or in effect, a representation of all possible formal processes, which leads to the idea that the Ruliad might not only underlie physics, but also mathematics, and that everything in mathematics, like everything in physics, might just be the result of sampling the Ruliad. Of course, mathematics, as is normally practiced, doesn't look the same as physics, but the idea they can both be seen as views of the same underlying structure. What makes them different is that physical and mathematical observers sample the structure in somewhat different ways, but since in the end both kinds of observers are associated with human experience, they inevitably have certain core characteristics in common. The result is there should be a fundamental law of mathematics that in some sense mirrors perceived laws of physics that we derive from our physical observation of the Ruliad. We've seen an example of this already in physics and in chemistry. A periodic table of elements was developed. This suggested an incredible order that led to quantum mechanics and to the description of how atoms behave. In metamathematics, there's a similar periodic table, but it's for what's called groups. So there's 20 fundamental different types of groups out there, and they deal with a variety of different symmetries. But hard as it is to believe, the study of these symmetries has led to 26 unique or sporadic or exceptional groups. One of these groups has it's called the monster group because it exists in a very high dimensional space. If I take the number 47, which is prime, multiplied by 59, which is prime, multiplied by 71, which is prime, I find that this entity, which is called the monster group, exists in 196,883 dimensional space. Now, I have no idea where this number came from, but it leads to something approaching 10 to the 53rd, 10 to the 54th, distinct representations of this, which is so huge I can't begin to describe it, which is why this is called the monster group. And this is a hint in the study of mathematics over centuries that there is some underlying order here, and we're just starting to see what it is. This table of the finite groups, which took literally hundreds, even thousands of mathematicians checking this to make sure they didn't miss anything. This is one of the great triumphs of modern mathematics, and it suggests there's really some fundamental order underlying mathematics. But what it is, just like with the periodic table of elements in physics and chemistry, it took a while to figure it out. We're not there yet. Most obvious manifestation of mathematics that we humans have developed is that the few million mathematical theorems have been published in the literature of mathematics. But what is there? Is there something that we could say that's metamathematics that's above it all that would suggest what's going on? And when we do physics, the traditional approach has been to start from a basic sensory experience, the physical world, and you have concepts like space, time, motion, then try to formalize description of these things, build on these formalizations. And for example, Euclid, mathematics took the same basic approach, but beginning a little more than a century ago, there emerged the idea one could build mathematics purely from formal axioms, without necessarily any reference to what is accessible to sensory experience. So there's a problem with that, which we've seen, which is that Gödel showed that there are things that you cannot prove that are outside the realm of the axioms. And having said that, that makes you wonder, what does it take to get something complete? But it appears that you can't ever come up with a complete set of axioms to describe everything. So the algorithms that go with this, that would be, I call them graphs. They're actually hypergraphs because they exist in a very high-dimensional space is what we think is going on here, and they get sampled in different ways so the behavior emerges that have regularities that we recognize, and they follow the core law of physics and mathematics. And this begins to suggest a new perspective, but the idea of the Ruliad is that a universe is based on some chosen underlying rule, like an axiom system that we might use in mathematics. But we have the entangled result of running all the possible rules, the rule of rules, all running at once in parallel everywhere. And this turns out to be an observer like us sampling the Ruliad must perceive behavior that corresponds to the known law of physics. So without making any choice, it's inevitable, given what we like as observers, that our experiences of the Ruliad will all result in the fundamental laws of physics. And perhaps there's a bridge to mathematics here, embodying all these computational processes that the Ruliad encompasses. And having seen that, what are these general laws of mathematics, just like we see the general laws of physics? The physicists have been at it in their own way and have developed what they believe is the theory of everything, where everything is really vibrating strings, and these strings resonate in different ways, and that creates the world around us. But having said that, that took a long time to come up with, and we're still at the stage where we're in our infancy of exploring what these concepts might really mean. Having said that, with physics, we have an idea that there's an actual physical reality that exists, but there's no underlying reality here. In mathematics, we just make a choice of some axiom system. But with this Ruliad, we could have underneath it all the same Ruliad for both physics and mathematics. And so therefore, just like physics is grounded in reality, so is mathematics. Now, when most working mathematicians do mathematics, it seems to be typical for them to reason if the constructs they're dealing with, be numbers or sets, are real things. But usually there's a concept that in principle one could drill down and formalize everything in terms of some axiom system. And indeed, if one wants to get a global view of mathematics and its structure as it is today, the best approach could very well be to work from the formalization that's been done with axiom systems. So in starting from this Ruliad and this Wolfram physics project, we're postulating a theory of mathematics, or a meta theory of metamathematics. And it's more efficient to start from what's, in a sense, the current prevailing underlying theory of mathematics, begin by building on the methods of formalizing mathematics and axiom systems. Over the past century, a certain amount of metamathematics has been done, looking at the general properties of these methods, but most often, when the methods are systematically used today, it's set up some particular mathematical derivation, normally with the aid of a computer. But here, what we want to do is think about what happens if the methods are used in bulk. So underneath everything, there could be a sort of specific, detailed, formal derivation being done. But what emerges is something at a higher level, something more human, and ultimately that corresponds to our experience of pure mathematics. How in the world would this work? Well, let's take an analogy. We begin with a gas, and it consists of many, many molecules bouncing all around, and they hit one another in various ways. But our experience as human beings with gas is a much more aggregated level, where we look not at the individual molecules, but we look at the gas as made up of a continuous fluid of some sort. And probably the same thing is true of mathematics, is that we have to step back and we'll start to see these metastructures here that include the notion of what would encompass a fluid, if you will, that we come up with in physics. So it's not obvious that this would be possible. And there's a lot of work going on in mathematics to try and link various areas of mathematics together. It was initiated in part by a mathematician named Langlands, and probably thousands of mathematicians today are working on linkages between the various areas of mathematics, including harmonic analysis, number theory, and things like quantum mechanics. Truly mind-boggling. In physics, the second law of thermodynamics is really understood from a point of view of computational irreducibility, where all the details, the microscopic details, are washed out so that the fluid dynamics just works. And we need the same sort of thing here for mathematics. We're just not there yet. Having said that, there's a lot of work going on, and we'll see that these people are the best and brightest, and we'll see what they come up with in doing all this. So the full story requires, in some sense, going below the level which we've recognized formal axiomatic mathematical structures, going to a level at which we're just talking about making everything out of complete abstract elements. In physics, we might interpret this as compartments of space. In mathematics, there's some sort of symbolic raw material below variables and operators and everything else that you come up with in mathematics. And the deep correspondence here between physics and mathematics might make one wonder whether the method we use in physics can be applied to mathematics and vice versa. In axiomatic mathematics, the emphasis tends to be on looking at particular theorems and seeing how they can be knitted together with proofs. And one could certainly imagine an axiomatic physics where one does particular experiments and sees how they can be knitted together. But there's an actual reality to physics that makes us seek broader laws, and there's probably something like that in mathematics as well. So what are we going to find? Some of it, in essence, just confirms impressions that working pure mathematicians already have, but it provides a definite framework for understanding these impressions, seeing what their limits might be, and it lets us address questions like why undecidability is so comparatively rare in practical pure mathematics, and why it's so common to discover remarkable correspondences between quite different areas of mathematics, such as this Langlands program. And beyond that, it suggests a host of new questions and approaches, both to mathematics and metamathematics, that help frame the foundations of this remarkable edifice that we call math. So with that, we're done. Have a wonderful evening, and we will catch you next time. All the best.